Okay, pre-cal students, in this video we will be looking at the characteristics of the graphs of sine and cosine functions. So your heading for today, your heading for today is this. Please copy this in your notes. We are looking today at the sine and cosine graphs. The sine and cosine graphs. Please include today's date with your heading. Now, like usual, I'm going to go very fast during the video. My philosophy is you can always slow it down, but you cannot speed it up. So you will probably have to pause the video a good deal during this video. Alright, here we go. Let's start off by writing down or copying down the sine function graph, okay? So go ahead and copy this in your notes. Notice we go over pi over 2 or 90 degrees, and then pi is 180 degrees, and then here we have 270 degrees or 3 pi over 2, and over here we have 360 degrees or same thing as 2 pi. Okay, notice at the highest point of the graph it goes all the way up to 1 right here at 90 degrees, and notice the lowest point of the graph is negative 1 over here at negative 90 degrees. And by the way, we have negative 90 here, negative 180 here, so on and so forth. Okay, and again, you're going to have to pause the video a lot and just write the information down as we go. It is let me go ahead and jump ahead to the last slide today. It is very important for you to understand everything we have looked at today. In a very soon upcoming video, we will be graphing sine and cosine functions. I will expect you to know these characteristics and the terms that I have used in this video. So please take some really good notes and pause the video, students, as much as you need to. Okay, here we go. First of all, you should have copied down this graph. Now this graph does continue on, so you can put arrows there if you want to. It would hit here and then start to come down again. Here it would hit at negative 1 and then start to come up again. And this graph continues on and on to the right and on to the left indefinitely. Okay? Now, let's start off with this term called the amplitude. And by the way, I apologize for not giving you the actual function. Here is the function. Please copy this in your notes. I apologize. Y equals sine theta. And this graph, this axis right here is your theta axis. It's not your x-axis, it's your theta axis. Okay? All right. And also in some problems in your book, they will call this an x-axis. If they do that, then they will have an x right here. Either way, it's the same thing. So the function we are looking at is y equals sine theta, or you could also say y equals sine x, okay? And that's what this graph is right here. It is a graph or a sketch of this equation right here or this equation here. So please include all of that in your notes. Okay, now let's go ahead and talk about the term amplitude. Please take some really good side notes. Let me kind of ramble here, and I want you to take some good notes. Notice how the graph here goes all the way up to 1, and it also goes all the way down to negative 1. So you could really say the total height of this graph from top to bottom is what? 2. Is it not? I mean, from here, from the middle up, it goes to 1, and from the middle down, it goes to negative 1. So the whole height of this would be 2. Well, listen, that is not the amplitude. The amplitude is not the whole height. The amplitude is always the entire height divided by 2. So the amplitude of this graph would simply be 1. Another way to look at the amplitude is so simple. Just find the middle of the graph and then see how high it is, 1. Or you could find the middle of the graph and then see how many units you go down. In this case it's 1, negative 1, but we still call that 1, so your amplitude is 1. The amplitude is always the distance from the center of the graph up or from the center of the graph down. Or another way to say it, the amplitude is always the total height of the graph, the sine graph, divided by 2. Okay? Now the period of a normal sine function is 360 degrees. Please write that down. Or you could also say 2 pi. Now you say, well, Mr. Earhart, what is the period of a graph? Well, the period of the graph is how far we go along the graph before it starts to repeat again. For example, please watch this. Take some really good notes. Notice the high point right here. And then if I follow the graph along, it goes down, up, and then as soon as it hits right here, it starts to repeat again. It starts to go down again. So if I were to compare high point with high point, the distance across from here over is 360 degrees. And you're like, it is, Mr. Earhart? Well, sure it is. Look, guys. Look. This is negative 270 degrees. Negative 3 pi over 2. So from here all the way over to here is 270 degrees. I mean, sure, it's negative, but it's still the distance is always positive, and the distance is 270 degrees. And then from here over to here is 90 degrees. So if you look at the total distance the graph covered from here all the way to here, that's 90. And then from here all the way to here, that's 270. So the total distance across is 360. And by the way, you could compare that with any part of the graph you want to. For example, look at this. Here is a part of the graph that's going through the origin, or going through the, here is a point on the graph that's going through the x-axis on the way up. Through the x-axis on the way up. Now, where do you see that again? Now, don't say right here. This is through the x-axis on the way down. That's not the same thing, okay? But look at this point right here. Look at this. This is through the x-axis on the way up. And guess what? What's the distance from this point to this point? Yep, you guessed it, 360 degrees. Okay, you could look at it like this. You could say, here's a point on the graph going through the x-axis on the way down. Where's the next point you see like that? Right here. Passing through the x-axis on the way down. And what's the distance from this green point to this green point? 360 degrees. Because from here to here is 180, and from here to here is 180. So the total distance from this point to this point is 360 degrees. So the period of a sine or cosine function is the distance the graph travels on the x-axis before it starts to repeat itself again. And a normal sine function graph has a period of 360 degrees, or 2 pi. Okay? All right, let's continue on. Now, let's take a look at the range. Now, if you've forgotten this from Algebra 2, let me kind of refresh your memory, okay? The range is what the graph is doing in respect to the y values. So the range goes from -1, comma, to 1. All right? This is called bracket notation. Okay? Let me go over this again. The range is how far the graph goes in relationship to the y-axis. So if I go to the highest point on the graph and draw a line, it's going to cross the y-axis at 1. And if I go to the lowest point on the graph and draw a line straight across, it's going to go through the y-axis at -1. So in other words, the range of this graph ranges from -1 up to +1. Now notice I used brackets. That means from -1, comma, to 1, inclusive. Brackets means inclusive. Okay? And notice the graph does go up to 1, so it's inclusive, and it does go down to -1, which is inclusive. So the range of a normal sine function graph is going to go from -1 to +1. That's the range, okay? Now the domain of a graph, if you'll think back to Algebra 2, the domain of a graph deals with the x values, okay? Well, if you'll look, I mentioned to you earlier, the graph continues on and on. It continues on and on, okay? And so because of that, there really is no limit to the domain. It's going to continue to go on and on to the right on the x-axis. It's going to continue going on and on to the left on the x-axis. So we would say the domain is this. We would say it goes from negative infinity. That's a symbol. It looks like a sideways 8, but it's a symbol for infinity, okay? So the domain goes from negative infinity to positive infinity. And I used parentheses instead of brackets because whenever you're dealing with infinity, you always use parentheses, okay? Because it's non-inclusive. In other words, it continues on and on and on. Okay, guys, I'm back. Sorry, my phone keeps ringing. Anyways, the domain would run from negative infinity to positive infinity because the graph does not stop. It continues on to the right and it continues on to the left. You need to know this information. Memorize it, know it well, okay? All right, continuing on. Now I'd like you to copy down the cosine function graph. And I should have included the equation. I apologize for not doing that. We would call this y equals cosine theta, or you could also say y equals cosine x, depending on what your axis is. In this example here, they're calling this horizontal axis right here, they're calling it x, as you can see right here. And so the name of this graph right here would be y equals cosine x. Okay, so there we go. Now, slide this over a little bit, get some room, and here we go. Notice it's a little different. Do you see the difference? Over here on the sine graph, the high point was over here at 90 degrees. On a cosine graph, the high point is at 0 right here. Okay? So let's go ahead and look at all the details. First of all, this would be 0 here, and then down here we have 90, and then 180, and then 270, and then 360. And over here, negative 90, negative 180, so on and so forth. Okay, so let's first of all take a look at the amplitude. Well, the amplitude of a cosine function, a normal y equals cosine x function, the amplitude is going to be 1, because remember, you take the total height, which is 2. The total height from here all the way down to here is 2. From here to here is 1, and from here to here is negative 1. So the total height is 2. 2 divided by 1, 2 divided by 2 is 1. Or you could just go to the middle of the graph and go from the middle up, or go from the middle down, and you'll see you get 1. So the amplitude is 1. Well, the period, let's see what the period is. Let's compare high point to high point, okay? So here's a high point, and the next high point is over here. Well, let's see what the distance is from this point here over to this point here, okay? This point here is at 0 degrees, and this point here is at 360 degrees. So it looks like the period of a normal cosine function is going to be 360 degrees, or you could say 2 pi, okay? Now let's talk about the range. Well, the range, it looks just like a sine graph to me. The highest the graph ever goes is 1, and the lowest the graph ever goes is negative 1. So the range is going to be negative 1 to 1. Negative 1 to 1. You always start with the smallest number first, negative 1, and then put the largest number second. Negative 1 to 1, and be sure and use brackets because it is inclusive. Now the domain is also going to be the same as your sine function, because think about it. We're going to have negative infinity to positive infinity, okay? Because the graph does continue on, and the graph does continue on and on. Okay, so because of that, there's no limit to what the graph does going to the right or going to the left. Okay, and don't forget, the range deals with your y values or your height and depth of the graph. Your domain deals with the x values, which is the behavior of the graph to the right and to the left. Okay, so the domain would be negative infinity. Let me get a drink here real quick. Negative infinity to positive infinity. Okay, now I read this before, I'm going to read it one more time. It is very important to understand everything we have looked at today. In a very soon upcoming video, we will be graphing sine and cosine functions. I will expect you to know these characteristics and the terms that I have used in this video. So please study this material well, students. Know it well. Go over it 2 or 3 times if you need to, but you are responsible for this information. Okay? If you have any questions, don't hesitate to call or email.